In this exercise we have two lines, L1 and L2. L1 is given by 2 points that it goes through, and L2 is given in the form of the vector equation of the line. And we want to know whether these two lines are parallel or perpendicular or neither. Now the most useful thing we can do for either the parallel or the perpendicular is to find direction vectors for each of the lines. For L1, let's say that the direction vector is V1. Actually, I shouldn't say the direction vector, a direction vector, because there's infinitely number. I mean, anything times a scalar will still be a direction vector. I'm just mentioning. But the easiest direction vector to find is the vector that would, the displacement vector that would take me from this point to this point. So what I'll do is say that direction vector for line 1, call it V1, one possibility is to subtract, say, 2 minus 4, 0 minus 1, 9 minus 5, which is minus 2, minus 1, 9 plus 5 is 14. Okay, now a direction vector for line 2, call it V2, can easily be seen from the vector form by taking the coefficients of the t in each of the components. So this would be, well, we don't have a t here, so the coefficient, it's like 0. It's like 5 plus 0t. So 0. Here, minus 9. And here, minus 4. Okay, no need to simplify. That's that. Now, this direction vector is parallel to L1. And this is parallel to L2. So in order for L1 and L2 to be parallel or not, it's the same thing as seeing if V1 and V2 are parallel or not. And how can we check if these two vectors are parallel? How do I know if this one or this one are parallel? Well, one of them has to be a scalar multiple of the other. Now, if the vectors are not 0, 0 is kind of one of those debatable vectors if it's parallel or not. But anyway, neither of them is 0. So one of them has to be some constant, a non-zero constant. Say V2 has got to be some non-zero constant times V1.